Hey guys, and welcome back. Let's go ahead and increase the number of maximum pods in our horizontal pod autoscaler so that we can further reduce the number of CPU shares that are being consumed by each of the individual pods in our cluster. Before we do that though, I actually do want to just quickly look at these two pods to see if they're running on the same node or if they're running on different nodes. So let's do a kubectl describe pod. And that'll just describe all three of the pods, including our client pod. And then we'll scroll up past our client pod. And so this is going to be one of our Nginx pods right here. And I just want to see which node he's running on. And he's running on 192.168.67.167. So 67.167. And if we scroll up a little bit more here, we should see the other node is actually running on 63.231. So the Kubernetes orchestrator has basically made a decision to put these two Nginx nodes onto different physical nodes, or sorry, two different pods onto two different nodes in the cluster, and that's helping to balance the load of the web application across multiple nodes in the cluster rather than having all of the pods sitting on the same physical virtual machine that's inside of our worker node pool. So we could also just confirm that by running a kubectl, and let's do top on nodes, and we should see a little bit of load on each of the nodes in our cluster. And it looks like there's substantially higher usage on the 67.167 node. You can see that that one's sitting at 102% CPU, and that probably will go up to 200% if both cores are actually being consumed. Actually, it looks like both cores are being consumed because we're sitting at about 1980 millishares, which is just shy of 2000 millishares, which would be full consumption of both CPU cores on this system. So it looks like it is actually using most of the CPU there, but then node number one here, the 63.231, he's only using about less than 20% of his CPU capacity. So what's probably happening here is that this 67.167 node probably had the client scheduled onto it. So let's just scroll up and confirm that. And right here under the Ubuntu client node pod, you can see that it has been indeed scheduled on the 67.167 node here. So that's why that other node is having such higher CPU consumption. So we have one pod running on each node for our web application, the Nginx container, and then the second node here has the client running on it, which we saw is taking up a pretty substantial amount of CPU power. And that's fine. This is just a test. This isn't a production application. We're just kind of playing around to understand how the horizontal pod auto-scaling feature works. So what we're going to do at this point is go ahead and uncap the number of nodes that our HPA allows. So let's do kubectl, and then we'll say autoscale. And let's do help here really quick. And we're going to actually just edit our auto-scaling configuration. So let's do kubectl edit HPA, and then the name of the HPA should be kubectl get HPA, and so it's going to be deployment Nginx website. So that's going to be our resource that we are editing here. And of course, we don't want to edit the deployment itself. We actually want to edit the HPA. So I'm going to do edit HPA Nginx website, and that'll open up our HPA resource inside of Notepad here. And you can see we've got our max replicas currently set to 2, our min replicas set to 1. So if we were to increase this and say, let's go up to maybe 6 as a maximum here, and then let's set our target CPU utilization to, let's say, 70%. And we'll save this, and we'll close that file, and that'll apply those changes. Now if we do a kubectl get all, we should see that the deployment controller has been updated with a new number of target pods. And the HPA is automatically going to scale that based on how many it thinks we need to have running. So let's go ahead and just wait for it to spool up and increase the number of pods on our deployment controller. All right, so it only took a second there, and sure enough, we have now 4 replicas of our Nginx pods running here. We now have 4 pods instead of the 2 that we had running right here earlier. It's still part of the same replica set because we haven't made any changes to the pod template itself. The only thing that's changing here is that the deployment controller is increasing the number of pod replicas on our application. So just a few seconds ago, the deployment controller and the replica set spun up these 2 new pods. So now we have 4 pods powering our website, and we still have just a single client. So if we do kubectl get all one more time here and take a look at our targets right down here, you can see that the balance of traffic we've actually got 2 more now, so we're up to 6 now, and our traffic has now been balanced by the service controller across all 6 of these pods, and our average CPU utilization for each of these pods has now decreased down to 61%, which is lower than our CPU threshold of 70%. So what we've done here is we've basically given the HPA, the horizontal pod scaler resource, free reign to go anywhere up to 6 pods, and it decided to actually go all the way up to 6 pods. And now that we have 6 pods, we've actually gone under the target desired threshold for CPU utilization, and so it doesn't really need to create any more replicas. So let's just give it a few more seconds to kind of balance out here. Let's run the get all one more time, and it looks like we've actually gone all the way down to 46%. So that's actually a really good thing, because we are now a very healthy amount below our target threshold. So if I was to edit the HPA again and say, well, I guess you could go all the way up to 10. So I'm going to limit you to 10 and close that. What do you think is going to happen here? Do you think it's going to continue to increase the number of pods, or do you think it's going to maintain 6, or do you think it's going to actually decrease? Well, the cooldown period takes several minutes to kick in sometimes, and so we're not going to see an immediate decrease here in the number of pods, but what you should see happen here is that the traffic has kind of balanced out at using 46% of each pod's CPU, and so the horizontal pod autoscaler is going to say, okay, well, 46% is well below the 70% threshold, and so I don't need to spin up any more pods. So I've given him free reign to go up to 10 pods. However, he's chosen only to go up to 6 replicas on our deployment controller. So if we were to add more traffic to our application and actually go back up past that 70% threshold, then the horizontal pod autoscaler would actually be able to increase the number of pods all the way up to 10. I'm going to create another Ubuntu client here, and we're going to go ahead and just do another siege on this one. So once this comes up and running, we'll just do an apt update and apt install siege --yes, and that'll get the siege utility installed in our second Ubuntu client container. And then we're just going to add some additional load. So we're just going to run siege and then to HTTP and biz website svc. That's our cluster IP load balancer service controller. And so now we've got a second one that's up and running here. So we've got 2 Ubuntu pods up and running here that we've interactively started siege on. So now what I'm going to do is open up a new tab in my Windows terminal here, and we'll just do a kubectl get all and kind of see what's happening here with respect to the horizontal pod autoscaler. All right, so it's still sitting at 6 replicas here, and we're still sitting at about 48% per pod here. And what's probably happening at this point is that our nodes are probably running at full capacity, and so we probably don't even have that much more CPU available. However, it looks like we have actually exceeded our target once more here. So actually, after that second siege client came online, it took a few seconds here, but it actually started increasing above that 70% threshold. So let's see what happens here again. All right, check it out. We actually increased to 8 replicas here because we added so much extra load that we need to actually spin up extra pods in order to support the application. And so now it looks like that target CPU is coming back down below 50%, very well below 70%, which is our threshold here. And so with the 8 pods running, we seem to have kind of balanced out here, actually. And so we're now able to see that our horizontal pod autoscaler has kind of calmed down at 8, and it's not going to bother increasing all the way up to 10. So now what happens if we remove the load entirely? So we'll do kubectl delete pod, Ubuntu client 10, misspelled that there. And then I'm going to also delete the second one. So we'll do another delete command for Ubuntu client 2. And after a couple of minutes, we should see that our target number of replicas right over here changes from 8 to some lower number. All right, so we've killed off both of our client pods here, and if we just run kubectl get all again, just so we can monitor our HPA resource here, you can see that our traffic has deteriorated significantly here. So now our average CPU utilization number is starting to drop far, far below our 70% threshold here. We've still got 8 pods running in our Nginx service here, and you can see that after both of those siege utilities are cleaned up, our CPU utilization actually drops down back to 0. We've got 8 Nginx pods running our business application, and we have dropped back down to 0. So we no longer need 8 replicas running because our target is 70%, and 0% is way, way below that. So after a couple of minutes here, we should see that number come back down. All right, so the HPA takes a couple of minutes to cool down after it's seen peak load there, and you'll see that it starts to actually decrease the number of replicas on the deployment controller. So we went from 8 down to 6. We got 6 pods running, and as the CPU continues to remain very low below the threshold, it will continue to scale down the number of pods running in our deployment. I hope this has been informative for you, and I'd like to thank you for viewing.